Today we're going to learn about derivatives. So, if you're watching this video, you probably don't know what a derivative is. We're just going to go over some basic ways to understand a derivative and find a derivative. So, what does a derivative of a function look like? You just hear the word, you don't know what it is. So, let's learn an important definition that will help us lead into derivatives. It's called the tangent line. A tangent line that just touches a curve at one point exactly. So here's a brief little description with a graph. So you see we have a parabola in the first quadrant, which is the graph of y equals x squared. Or you can write it as f of x equals x squared. So really, when we're talking about the derivative, we're using tangent lines to find an approximation or an exact value of the at a point. So I won't reveal what that is yet, but we'll find that throughout the video using another method. So that line touching the curve at that singular point is called the tangent line. So how does this relate to the derivative? So it comes down to the point that the derivative at the point is equal to the value of the slope at the tangent line. So if you think about it, it makes sense because if they're exactly the same and they're touching, they have to be headed in the same direction. So you may wonder, how exactly do we come up with a number for this derivative? And can we find it numerically? Well, it turns out the answer is yes. The way we do it is using something called the limit definition of the derivative. So now what we want to do is find an equation to determine the derivative of a function in general or at a point. So something we can use to say, okay, the derivative at x equals 1 is blah, 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 and the derivative at x equals 2 is blah, blah, blah. Or we can just say the derivative at any point is represented by a function f of x equals blah, blah, blah. So we're looking at the same function as before. This is a graph of the function f of x equals x squared in the first quadrant, of course. So now we're going to put our tangent line to work and find and use the limit definition of the derivative to find an expression for the derivative. So we have a little drawing there, and now we're going to find a point on the graph. So we can match a tangent line to that point. So we're going to select the point. We're going to select the point 1, 1, and we're going to draw a tangent line there. So the point 1, 1 meets perfectly in the first quadrant, and so we want to find the slope at this point. We know this point exists, and we know there must be a tangent line. So now to find that, we're going to use something called the limit definition of the derivative, as I mentioned previously. So this is the definition. F prime of x, which is denoting the derivative at any point, is equal to the limit of f of x plus h minus f of x over h as h goes to 0. You can write that down if you need to. That might take a second to write down. So this relationship can tell us the derivative of a function using a point-slope approximation. So now let's return to the same function to find an approximation using this. So what we're really doing is we're just plugging in our function, which is, in this case, f of x equals x squared, into the limit definition of the derivative. We're canceling everything through, and then we come down to a certain, we're coming down to a certain expression that represents the function f prime of x that can be used to find the derivative at any point, or any value of x, which has a corresponding derivative, which is the slope of the tangent line at that point. So we have our graph f of x equals x squared. So now we want to find a function that can represent the slope at any point, or the slope of that tangent line at any point. So if we plug in x squared to that, we get the following. Limit of x plus h squared minus x squared over h as h goes to 0. So Then, after some foiling and some canceling, we get the following, which, it will always simplify. And in some cases, the denominator will go to 0 and it will look undefined, but you just have to cancel more terms or move the denominator to the numerator. So we get the limit of h plus 2x, which is equal to f prime of x, which is equal to 2x, since h is going to 0. That's the important part. The h's should always cancel out because that's just a very small number. It's going to the point. So since we know that f prime of x equals 2x, the slope at x equal 1 is f prime of 1, which is equal to 2, because 2 times 1 is 2. So the slope at this point is therefore 2. And this is really what a derivative is, in essence. This is one way to find the derivative. And it's a surefire way. It might prove more tedious than other options, but it works. Thanks for watching, and have a good day.